Good day, viewers. You are welcome back to class. As you already know, my name is Israel. In today's discussion, we are going to handle a topic in chemistry, actually practical chemistry, which is volumetric analysis, otherwise also referred to as titration. In this titration, we have carefully selected a topic which you have to actually settle down, look at it very well, and understand the basis, so that in case you encounter similar question, you want to tackle it. Even if similar questions are not encountered, the first few part of it is very, very important that you understand, because whether you like it or not, those are the pattern they are still going to bring. So let's get started and see how it goes. E is a solution containing 0.1 mole per GQ of acid. F is a 0.1 mole per GQ SOH containing 4 grams of SOH per GQ of solution. Put into the burette and titrate with 20 or 25 cent portion of F using phenolphthalein as indicator. You can see most of the ones you have been encountering is methyl orange. This time around, we are going to use phenolphthalein. That's the essence of this practical. So you can see a difference, because the indicator normally used in secondary school is either methyl orange or phenolphthalein, and they can bring anyone for you. You have understood, I believe you have been looking at the one of methyl orange. So have a look at how phenolphthalein will look like, so that in case they give you phenolphthalein in the coming Waec, it will not be strange to you. So record the volume of your pipette, tabulate your burette readings, and calculate the average volume of E used. From your results, calculate the amount of SOH in 25 cm cubes in terms of mole, mass of HCl, the average volume of E used, mole ratio of HCl to SOH, relative atomic mass of S. So how do we do it? You look at it, put into the burette and titrate. Before you do that, put your table first. You say volume of pipette 25.0 cm cube. If you look at it, the one used in the school I work is usually 25. You will have to check your own. You normally 20 or 25 in various schools. If your own is 25, which is the common one, you indicate it. Usually some examination body, they start your mark there, like NECO in particular. Sometimes Waec also do the same. This volume of pipette is 1 mark, so don't miss it. Those are giveaway marks. Then you have the table, titration table. You like use capital letter, whichever one, they don't penalize for that. You have first cm cube, second cm cube, third cm cube. Make sure you write a centimeter cube or cubic centimeter. If you don't indicate this, you write centimeter. It's a unit of measuring length. They will mark it wrong. You lose mark. Don't lose your mark unnecessarily. This table is usually a giveaway. Though you have here, let's shift it a little. First, second, third, say final burette readings. Initial burette readings. Volume of acid used. You can see it. You have a good table now. So people prefer to draw to 4, 5, but even if you draw 100, they are going to pick only 2. You call those two concordant. When you say 2 concordant, that is 2 that are closest. They must remember, in all the titration you are going to do, you must have 2 that don't differ by plus or minus 0.2. That is plus or minus 0.2. If you have anyone that, if the 2 you are going to use differ by more than this, you start losing marks. Try not to lose your marks. So this is the table we have, a very good way of drawing the table. Then we start. This is the acid, it has been filled. Remember the precaution I gave to you the first video. If you are not okay with it, go back to that first video. Please go back to that first video. Understand this very well, because in that video, I remember I didn't carry out any calculation. I only told you how to draw a perfect table. As in perfect table, where you not lose any marks. Remember this table is 8 marks. To the averaging 11 marks. 1 mark here, 8 marks on the table, 2 marks on the averaging, making 11 marks. I taught you properly how to draw a perfect table. Go through them and really understand the precaution. However, as many as I can remember in this video, I will also chip it in. So for example now, before you start, you must rinse the burette with the acid to be put on it. Rinse a clean burette. You don't talk about washing. The white marking does not recognize washing. All they recognize is rinsing the burette with the solution to put in it, and you must not stop there. If you stop there, they will not give you any mark. You also say rinse the pipette with the base to be put in it, then you have a complete mark. Most often they say rinse the burette and pipette with the solutions to be put in them. That one summarizes everything, so don't make mistake. Then remember also, you rinse a clean conical flask with water. That is all you need for the first few precautions. So this one, we already filled it with acid from 0 to 50. So that one is already filled. And this is the base. We are going to pipette it and then drain it through. So we are sucking it. Allow it to flow through, to drain through. Remember, 3 is enough. Move the 3, pick 2 concordant. It's still draining. You have to be patient. And remember, another precaution, you must not blow the last drop with your mouth, because the manufacturer, as I told in the first video, has already constructed this thing in such a way that the pipe in such a way that there's always a last drop. Any attempt, because they may ask you, why must you not blow the last drop? Any attempt to blow the last drop will now increase the volume. So you don't do that. This is the phenolphthalein. We are going to add the indicator now. 2 drops. I've already added 2 drops. You see it. Methyl orange is supposed to be yellow. You see it. Now, if it's methyl orange, it's yellow to orange. When you are titration, you don't need to look up. Just be concentrating on what you are doing. It has changed. You can see it has changed to colorless. So the point where it changes is 23. 22.5. 22.5. Let's see it. Final burette reading 22.50. We are starting from 0. Since you have enough solution, we just make all of them 0, 0. Remember in the first video, I told you how to do it. Even if your solution is not enough, how you can start from where the previous one stopped. Please go through it very, very well. So let us, we'll top it again. Remember, you must remove your funnel. You must, before you start titration, remove air bubbles from the burette and also from the pipette. If you say from the burette, they will not give you any mark. You must, in the both tools which you are using for this experiment, if you apply it to burette, you must apply it to pipette. Don't forget that. Remove air bubbles from the burette and the pipette. How do you remove air bubbles? Go to my first video. You can see this space. You will see some air bubbles. When you are titrating, you see the thing moving up and down. You see air space. You have to allow it to flow through with force. Flow through with force. The thing will cease. It will block itself. So there will be no air bubbles again. Then you now have to put your funnel again and increase the volume so that it can get above the zero. Then you now reduce it again to zero. That is what I'm doing now. Okay, so it's at zero mark now. The next thing, you rinse every time you titrate. When you finish, rinse this conical flask with water, which I've already done. Then the next thing is to repeat the process again. That is, we do the last one and we start our calculation. It's flowing through. And remember, when you are pipeting, you don't need to discuss with anybody. Most students, they encounter problem by drinking, or at times the solution rushing into their mouth because they are talking. When you are doing this activity, you don't need to talk. Because by the time you talk, you may mistakenly remove the tip of the pipette from the solution. As a result, air will rush into it and it goes straight into your mouth. So that is why you have to be careful and don't talk when you are doing it. And when your solution is too small, you have to make report to whoever is supervising you so that it can give you additional one. Those are the problems you have when you are titrating. But that is not a precaution. I've only given you 3 precautions so far. Go to my first video, you get everything in detail. The first precaution I gave to you, rinse a clean burette. A clean burette. I didn't say wash. They don't accept wash when they are marking. Rinse a clean burette and a clean pipette with the solution to be put in them. That is 1. 2, remove air bubbles from burette and pipette before starting your titration. 3, rinse the conical flask with water and not with acid or base. Rinse it with water. As you progress, I'll tell you. You can see this is a sheet of paper, white. You can say use a white paper or white tie. The essence is for you to know exactly when the color will change. So I'm going to put 2 drops of indicator again, phenolphthalein, as we already said. 2 drops, 1, 2. Follow the processes. The one the teacher will teach you in school, the concentration may vary from this, but for Waec, it's always the same thing. So this titration we are doing is based on concentration which the teacher used, which I used to prepare it. The one your school will use to prepare for you may be different during practice period, but for Waec, usually similar. And again, remember, the end point you will have here, if you are doing it, you cannot apply it to your school. It has changed. 23. .00. You see it? So we'll do the last one. Remember, you cannot use my endpoint. The other part of the calculations are the same, but you must use the endpoint you obtain from your own school. That's what makes the difference. You use another school's endpoint, it will not give you the good result. It's the one your teacher used or he directs you to use that you must use, not my endpoint, because I'm not your teacher in your school. However, the other calculations, okay, I've topped it to 0 mark again. Next thing is to pipe it. can see I'm watching it when I'm doing it to avoid accident of rushing to my member. That one is not a precaution. Just for your safety. The last precaution I will give you, for further precaution, there are many I gave you in the first practical. Go and consult it, how to carry out a perfect titration. You will see it there. So the last precaution is, you can see some people when they are looking at it, they refuse to concentrate and get the actual mark. So you say avoid error due to parallax. Your eye will be moving up and down. Avoid error due to parallax when taking your burette and pipette readings. So that will be okay. For further for more precautions, go through my first video, which I know many of you have consulted, so that we can do this one and finish it on time. So this is the last titration. I'll give you 4 precautions. Then my first video, I think there are more than that. It's still draining through. Remember, you must not blow the last drop. Don't ever forget that. I think that makes it 5. Usually they are asking you 4, 2. They hardly ask 6, 5. Just say still 2 precautions. Very rare they say state 4, but no minimum of 4. They are simple now. There's nothing in it, so that you can do well. I use the tip to touch the side of the conical flask. Anyone that drains through, you know that's the maximum you can take. Don't ever blow the last drop. You can see there's still a last drop. It will not leave. The manufacturers have already done it in such a way that that last drop will always be there. Any attempt to blow it, you have increased the volume and will not give you accurate result. So this one is the last 2 drops. If you have any question, the comment section is there where to consult it. If you are good in it, you don't even need to go out to be looking up. Just be concentrating on what you are doing. For better titration, go through my first video. You see it has changed. Wow, it has changed. 23 dots. So you see the third titration, 23.00. So the next thing is for you to subtract 0 away from this, 23.00, 23.00, 22.50. Remember we said 2 concordant. They must not differ by more than plus or minus 2, or plus 2 or minus 2, which is plus or minus, sorry, not 2, 0.2, 0.2, plus or minus 0.2. If you look at it, this 22 away from this is 5, is plus 5. So we cannot use this. These are the same. So you now say volume average, volume of acid used. You pick the 2 concordant, the one that doesn't differ by plus or minus 0.2. That is, if you subtract it, the difference is no more than plus or minus 0.2. If you, whichever way you do it, difference must not be more than that. So it will now be 23.00 plus 23.00 over 2, 46.00 over 2, 23.00 cm3. 2 decimal places. Always ensure that your volume is always on 2, is always correct to 2 decimal places for this average volume of acid. From now, it's 3 significant figures. Don't forget that. Till you get to this average is 2 decimal places. You can see the readings, 22.50. You cannot say 22.5. You must add 0 to make it 2 decimal places. And you must not say 22.51 is not accepted. They will mark it wrong, completely wrong, because the burette is not calibrated to that sensitivity. It's only 22.5, but you will not add 0 to make it 2 decimal place. So the average volume of acid we are using is 23.00. So we are through with this first one, calculate the average volume of acid used. Then the second one, from your result, calculate the amount in moles of SOH in 25 cm cube of solution B. So let's see if we can remember our VA is 23. So let's put it somewhere so we don't forget. VE 23.00. We don't forget that. So we wipe it, and we can wipe it and leave it like that. Leave only that value. So you can see it from your result. Calculate that is B now. You can share it. B, Roman figure 1. From your result, calculate the amount in mole of SOH or SOH in 25 cm cube of solution F pipetted. That's volume of pipette is 25 cm cube. Then you know that F is 0.1. So you say F equals 0.10 mole per dm cube. Remember in our first video, we said when you have the same thing as 0.10 mole per 1000 cm cube. 1000 cm cube is 1 dm cube. So you now say, I know that our VF, volume of pipette, VF is 25.0. This one is 0.0 cm cube or 00, whichever way you put it is okay. 25.00 cm cube. So 25.00 cm cube. Let us maintain 2 decimal places. They'll mark it for you. You will not say, hence, you say 1000 cm cube equals 0.10 mole. Therefore, 25 cm cube equals X. You cross multiply. S times 1000 cm cube equals 0.10 mole times 25 cm cube. Let's just make it correct substitution. 25.00 cm cube. 25.00 cm cube. Don't say it doesn't matter. It matters a lot. X will now be 0.10 mole times 25.00 over 1000 cm cube. Cm cube cancel cm cube. Let's solve it and see what we have. But please ensure when you are solving it, you don't make mistake. 0.10 times 25 give you divide by 1000. 2.5 times 10 to the power minus 3 become 2.5 times 10 to the power minus 3 mole, which is 0.0025 mole. That's for F. Then that's for F. Remember in your school, if your school uses 20, 20 will be here. Volume of pipette. That's the volume of base. The Roman figure 2, mass of HCl in the average volume of E used. Roman figure 2. To calculate that, they say average volume of E used. Therefore, you must convert it to this first, number of mole. You now say 0.100 E equals 0.10 mole per dm cube. But we know that the average volume VE is 23.00 cm cube. You now say 1000, just like we did the previous one, cm cube equals 0.10 mole. Therefore, 23.00 cm cube equals S. Cross multiply. S times 1000 cm cube equals 0.10 mole times 23.00. S equals 0.10 mole times 23.10 all over 1000 cm cube. 23.00 cm cube. Cm cube cancel cm cube. So you have 0.10 times 23 give you, divide by 1000 give you 2.3. Let's do it again. 0.10 times 23 give you divide by 1000, 2.3 times 10 to the power minus 3 becomes 2.3 times 10 to the power minus 3, which is 0.0023 mole. You can see it. Good. But that's not the question they say we should calculate. It's a mass of HCl and the average volume of E used. Mass. We now say mass is taken as reacting mass. Reacting mass equals number of moles times molar mass. Note that number of moles is 0. Let's put asterisk here. 0.0023 times molar mass of HCl, because they specified it. It's a mass of HCl times 1 plus 35.5. Remember, it is stated under H is 1, Cl is 35.5, which gives you 0.0023 times 36.5. Let's see what it gives us. 0.0023 times 36.5, 0.08395. 0.08395. Let's check it again. 0.08395. So they don't accept false significant figure. You now say equals 0.083840 gram. You see it. Once you approximate it to this one becomes 0. 3 significant figures. Don't make that mistake. So that is how that one goes. Then the other one is mole ratio of acid of HCl to SOH. You just write it like this. H, that's question 3. HCl SOH. Mole ratio. F is the SOH, which is, for F, you have 0.0025. 0.0025. HCl 0.0023. Both of them are moles. You now divide by the smallest. You have 0.0023 over 0.0023. Ratio 0.0025 over 0.0023. One ratio. Remember, when you are calculating empirical formula, don't forget that you normally divide by the smallest to get the mole ratio. And they told us here to find the mole ratio. So we can remove this one now since we don't need it again. So it now becomes 0.0025, 0.0025 divided by 0.0023 give you 1.0869. 1.0869. 1 ratio 1. So that's the mole ratio of HCl to SOH. Last one, relative atomic mass of S. So let's clean this side to calculate the relative atomic mass of S. Relative atomic mass of S of X. Remember, S is a part of SOH. And they said F is 0.1 mole per day cube SOH containing 4 gram. 4 gram is the reacting mass. This is the molar mass. Calculate relative atomic mass from relative molecular mass. We say molecular mass equals reacting mass over number of moles, which is 4.0 gram. This is 4.0 gram over 0.10 mole. 0.10 mole. Let's see what it gives us. 4 divided by 0.1 give you 40. So it gives you 40 gram per mole. That's what you have. So then to calculate relative molecular mass, you say SOH equals 40. S plus 16 plus 1 equals 40. Remember they told you O is 16. Look at it here. Oxygen equals 16. S plus 17 equals 40. S equals 40 minus 17 equals 23. So the relative molecular mass is 23. Thank you very much for watching my video. This is a very simple method of calculating. Remember, this method we used is not the There are usually two methods. I decided to change the pattern this time around in case they give certain questions that you may find it difficult to use that method. You can look at the question. There is no equation here. However, if I want to solve it using that the one they normally call cover, CAVA over CBV equals NA over NB, I can also solve it with this. Use this. I can also solve this question with it. But the easiest method is to use this one. This one is known as first principle. First principle. You see it? That's the method we use. Because some students will be confused. Say no equation. They didn't give us equation. There's no equation in this question. They didn't give you. So it is easier to use first principle using the method you already be taught, probably in your SS2 under stoichiometry, mass and volume relationship. In that case, you want to solve it. This method again is known as method using the first principle. It's different from CAVAs, but you will get the same answer, you'll get the same mark. So study this method very well. It's better you apply it to this. Thank you very much. Please, if you are not subscribing, kindly subscribe. And if you have been subscribing, do well to share it. Share it to your friends. Let them also benefit. As you are moving ahead, they should also move ahead in life. That's what makes friendship. Thank you very much. God bless you.